Welcome to another requested work solution. Today we're going to be looking at exercise 14C question 8, and that comes from the Cambridge IGCSE maths textbook by Pearce, which was published in 2011. Okay, so we have a car and a motorbike start at the same time and travel in the same direction. Okay, so this is them starting at the same time, and their speeds are shown on the speed time graph. Okay, it's really important that we understand it's a speed time graph because there's certain features of a speed time graph which we need to be aware of. And let's look at our first question here. Our first question is, part A. All right, so what is the initial acceleration of the motorbike? So acceleration is what we're looking at here. So acceleration. Now, in regards to a speed time graph, acceleration, and we'll start with A, acceleration is going to be equal to the gradient or slope of the line. Okay, so the gradient or the slope it represents the acceleration of the vehicle that we're, or the acceleration of the particle or whatever we're talking about, but in this case, the motorbike. Okay. So to figure out the gradient or the slope of a straight line, we know that the gradient, M represents the gradient, is going to be equal to the change in y, so y2 minus y1. This is going to require two coordinates, okay, over the change in x, x2 minus x1. Okay, so let's choose two coordinates. So we're talking about our initial acceleration, and we can see that the initial acceleration starts at 0, 0, and it's the same, the gradient or the acceleration is the same up to this point up here. So I'm going to choose these 2 points. You could choose other points if you wanted to, but I think it's easier working with zeros, and it's just nice. Graphically, you can see the 2 points that I've got here. So I've got my first point here, which is 0, 0. I'm going to label that as x1, y1, and my second point up here is going to be 10, 20. That's going to be x2, y2. Now, I've chosen this to be my first point and this to be the second point, but it does not matter in which order that you do it, you'll still end up with the same gradient. Okay, so we're going to substitute those values into our gradient formula. So my y2 is 20 minus my y1, which is 0, over my x2, which is 10, minus my x1, which is 0. And we'll end up with 20 minus 0 is 20, obviously, 20 over 10, and we're going to end up with 2. Okay? Now, when we're talking about acceleration, that's going to be meters, 2 meters per second squared, or per second. So the answer to part A is 2 meters per second. All right. Now let's look at part B here. When they are travelling, so what is it? When they are travelling at the same, when are they travelling at the same speed? All right. So let's have a look at this part here. This is the speed here. This tells us the speed, and we can see that they actually cross over at this point here. Okay, so they're traveling at the same speed. They're both going at the same speed at this point here. Here, obviously, the car's going faster and the motorbike's going slower, and over here, the motorbike's going faster and the car's going slower. So this is the point at which they're travelling at the same speed. And I can see that they're travelling at the same speed at 20 seconds. So B is 20 seconds. All right. It's done there. So how far apart are they at that time? All right, how far apart are they? Now we're talking about distance. Now distance, when we're talking about speed times graphs, distance is equal to the area under the line. Okay, before we saw that acceleration was the gradient of the line. Now distance is the area of the line. And we want to know how far apart are they at this particular time here, at 20 seconds. So how far has the car travelled in 20 seconds, and how far has the motorbike travelled in 20 seconds? And we want to find the difference between those two. Okay, so let's look at the car first. So we're looking for the area of the line between 0 and 20 seconds. So the car the distance that the car's travelled is going to be the area under this line here, and we can see that we have a triangle, all right? And the area of a triangle is going to be half base times height, so it's going to be half the base, which is 1020 times 20 times the height. So between 20 and 20 is 20. Okay, so that's going to be equal to, right, the distance that we've travelled is half times 20 is 10, 10 times 2 is 200 metres. All right, now the motorbike. So how far has the motorbike travelled? Well, we need to figure out the area under the line of the motorbike. Now, we only had one shape here to find the area under, which was the triangle there, but if we have a look at the motorbike, we can break that into two separate shapes. So we can break that into a triangle and a rectangle. Okay, so we can find the area of this triangle and we can add that to the area of that rectangle. So the motorbike, okay, its area is going to be the triangle plus the rectangle. So the triangle is going to be half of the base. So half times the base of this triangle is 10. Okay, times the height of the triangle, which is 20, times 20. All right, and we're going to add that to the area of our rectangle. So our rectangle is going to be 10 by 20. 10 by 20. Okay, and that's going to be equal to half of 10 is 5, 5 times 20 is 100, plus 10 times 20, so is 200, so it's going to be 300 metres. So the difference, or the distance apart they are, is going to be distance apart equals 300 minus 200, so that it's equal to 100 metres. All right, so the distance apart is 100 metres. Now the last part of this question is, how far does the car travel when it is moving faster than the motorbike? So let's go back to our graph. At this point here, they're moving at the same speed, but the car continues to accelerate here, where the motorbike goes at the same speed. So it accelerates further past the motorbike. So from here upwards, it's actually travelling at a higher speed than the motorbike. So we need to figure out the area underneath here to figure out the distance that it is travelling, that it actually travels. So if we have a look, we can break this into a number of different shapes. It's up to you. But I can see one big square there, okay? I can see a rectangle here and a small triangle there. So the distance in this case, so for C, so the distance is going to be equal to the area of the triangle, so that's going to be half times 10 times 10, okay, plus the area of this rectangle here, so it's going to be 10 times 20, 10 times 20, plus the area of this large square here. So we've got 10, 20, 30, 30 by 30. Okay, so the distance, total distance, is going to be 50 plus 10 times 20, 200, plus 30 times 30, plus 900, which will equal 1150 meters. Okay. Thank you for watching. Now, if you have any other, if you need anything to be clarified, please comment below. If you have any other questions that you'd like me to do, please also comment below with other questions that you'd like a work solution for. Other than that, have a great day.